Good day, students. Today, we embark on an exciting journey to explore the fundamentals of scientific investigation. In this presentation, we'll delve into essential topics such as measurement units, physical quantities, the scientific method, and the importance of fair testing. So, fasten your seatbelts as we navigate through the fascinating world of science. By the end of this lesson, you'll have a solid grasp of these concepts and be well prepared for exciting experiments and scientific exploration. Let's get started. Let us start by delving into the world of scientific investigation, and a crucial part of that is understanding measurement units. Think of measurement units as the building blocks of science. They help us quantify the world around us. We've got two categories of measurement units: basic units and derived units. Basic units are those we measure directly, like using meters to measure length or seconds for time. These are the absolute foundations of measurement. Derived units, on the other hand, are a bit more complex. They're combinations of basic units. For instance, when we measure speed in meters per second, we're using a derived unit. Why is this important? Because understanding measurement units is like learning the language of science. It's how scientists from all around the world can communicate and understand each other's work. So, as we continue, keep these measurement units in mind. They're the cornerstone of scientific investigation. Now we're going to dive into the exciting world of physical quantities. Think of these as the building blocks of science. They help us measure and understand the world around us. Today, we'll explore what physical quantities are, and I'll give you some real-life examples to help you grasp these concepts better. So, what exactly are physical quantities? Well, they are properties of the world that we can measure. These measurements are essential for scientific investigation. Think about it this way: when we describe something, we use words like big, heavy, or hot. In science, we need precise ways to describe these characteristics, and that's where physical quantities come into play. Let's look at a few common examples of physical quantities. 1. Length. This one's pretty straightforward. It's all about measuring how long something is, whether it's the height of a mountain or the length of your classroom. Length is a crucial physical quantity. 2. Mass. Mass tells us how much matter is in an object. Imagine you're comparing a feather and a brick. Mass helps us understand why the brick is much heavier than the feather. 3. Time. Time is a physical quantity we're all familiar with. It helps us measure events and durations. From seconds to years, time keeps our world ticking. 4. Temperature. When we talk about how hot or cold something is, we're dealing with temperature. It's a vital physical quantity for weather forecasts, cooking, and understanding the universe. Now, physical quantities can be divided into two main categories: fundamental and derived quantities. Fundamental quantities are the basic ones that can't be defined using other physical quantities. Length, mass, time, and temperature are examples of fundamental quantities. They're like the ABCs of physics, the building blocks of everything else. Derived quantities, on the other hand, are created by combining fundamental quantities. For example, speed is derived from dividing the length of a journey by the time it takes. You can't measure speed directly. You need length and time to calculate it. Understanding these categories is crucial because they help us organize and simplify the complex world of measurements.
We hope you have enjoyed this science lesson. If you do, don't forget to give it a thumbs up, share it with your friends, and subscribe to our channel for more exciting educational content. Thank you for your support.
Great, students. Now that we understand what physical quantities are, it's time to talk about how we actually measure them. This is where the rubber meets the road, so to speak. So, let's dive into the world of measurement. First things first, how do we go about measuring physical quantities? Well, it's all about using the right tools and techniques. Think of these tools as your trusty sidekicks in the world of science. Let's take a look at some essential tools for measurement. 1. Ruler. The humble ruler is a go-to tool for measuring length. Whether it's the length of a pencil or the width of your notebook, a ruler provides precise measurements in units like centimeters or inches. 2. Balance. When it comes to mass, we turn to a balance. This nifty device helps us compare the mass of different objects. It's especially handy when you need to figure out how much flour to use for that chocolate chip cookie recipe. 3. Stopwatch. Time, as we mentioned earlier, is crucial. A stopwatch allows us to measure the duration of events with precision. Whether you're timing a race or your favorite video game speedrun, a stopwatch is the tool for the job. 4. Thermometer. Temperature can vary significantly, so we need a specialized tool to measure it accurately. The thermometer comes to the rescue. It helps us determine how hot or cold something is, and it's essential in fields like weather forecasting and healthcare. These tools are like your scientific superheroes. They help us collect data and make sense of the physical world. And remember, using the right tool for the job ensures accurate measurements. Now that we've covered the fundamentals of measurement, let's delve into the exciting world of scientific investigation. So, what exactly is scientific investigation, and how does it work? Well, that's precisely what we're about to explore. Scientific investigation is like solving a mystery. It's a systematic process scientists and researchers use to explore and understand the world around us. Just like Sherlock Holmes would use clues and evidence to solve a case, scientists use specific steps to uncover the secrets of nature. The components of scientific investigation are as follows. 1. Observations. It all starts with keen observations. We notice something interesting or puzzling in the world, like plants growing towards the sunlight, and we want to understand why it happens. 2. Research and background. Next, we gather information through research. We study what others have discovered about similar phenomena, which helps us build a foundation for our investigation. 3. Hypothesis. Armed with knowledge, we form a hypothesis, a fancy word for an educated guess. It's our best explanation for the observed phenomenon. For example, we might hypothesize that plants grow towards sunlight to get more energy for photosynthesis. 4. Experimentation. Now, it's time to test our hypothesis through experimentation. We design experiments to collect data and gather evidence. In our case, we'd set up controlled experiments to see how plants respond to light in different ways. 5. Data collection. During the experiments, we meticulously collect data, numbers, measurements, and observations. This data helps us evaluate our hypothesis. 6. Analysis. After we've gathered enough data, it's time for analysis. We crunch the numbers, create graphs, and look for patterns. This step is critical in drawing meaningful conclusions. 7. Conclusion. Finally, we draw conclusions based on our data and analysis. Did the results support our hypothesis? If so, great. If not, it's back to the drawing board to refine our ideas. These 7 components make up the scientific investigation process. It's a journey that requires curiosity, critical thinking, and attention to detail. But it's also incredibly rewarding because it allows us to unlock the mysteries of the natural world. So, as we continue our exploration of scientific investigation, remember that every great discovery, from understanding gravity to curing diseases, started with these fundamental steps. You too can be a scientific detective, uncovering the hidden truths of our universe. Now we will explore the fascinating world of FAIR testing. You might be wondering, what exactly is FAIR testing, and why is it so crucial in scientific investigations? Well, let's dive right in and find out. What is FAIR testing? FAIR testing, also known as a FAIR test or a controlled experiment, is a cornerstone of scientific research. It's a methodical approach that allows us to investigate a single variable, while keeping all other factors constant. The goal? To ensure that our results are reliable and truly reflect the impact of the variable we're studying. Now, why is FAIR testing so important? Let's explore a few key reasons. 1. Reliable results. FAIR testing ensures that our results are trustworthy and accurate. By isolating the variable we're interested in, we can confidently say that any observed changes are a direct result of that variable, not other factors. 2. Reducing bias. It helps us reduce bias or personal opinions from creeping into our experiments. Science is all about objectivity, and FAIR testing is a way to maintain that objectivity. 3. Repeatability. When we conduct experiments fairly, it becomes easier for other scientists to replicate our work. This is a crucial aspect of the scientific method. Multiple researchers should achieve similar results when following the same procedures. To truly understand FAIR testing, we need to demonstrate it in our experiments. Here's how it works. Imagine we want to test how different amounts of sunlight affect plant growth. To conduct a FAIR test, we would 1. Keep all other factors constant. Everything else that can influence plant growth like temperature, soil, and water must remain the same. 2. Vary only one thing, in this case, the amount of sunlight. We might expose one group of plants to full sunlight, another to partial sunlight, and a third to shade. 3. Collect data. We carefully measure and record the growth of each group of plants over time. 4. Analyze the results. By the end of our experiment, we can confidently say whether the amount of sunlight had a significant impact on plant growth, because we've controlled for all other factors. This process demonstrates the essence of FAIR testing. It's about creating a level playing field in our experiments, where the only difference between groups is the variable we're investigating. So, as budding scientists, remember that FAIR testing is your key to uncovering the truths of the natural world objectively and reliably. It's a skill that will serve you well in your scientific endeavors, allowing you to make discoveries that can change the world. Congratulations, young scientists, on a fantastic exploration of the basics of scientific investigation. We've covered a lot of ground today, so let's take a moment to recap the key points that will stay with you as you embark on your scientific journey. Measurement units. We've learned about the fundamental and derived units of measurements, essential tools for quantifying the world around us. Physical quantities. You can now recognize and understand various physical quantities, from length and mass to time and temperature. Remember the distinction between fundamental and derived quantities. They're the building blocks of scientific measurement. Measuring physical quantities. We explored how to measure these quantities using tools like rulers, balances, stopwatches, and thermometers. Precision is the name of the game. Scientific investigation. Delving into the exciting world of scientific investigation, we discovered its components: observations, research, hypothesis, experimentation, data collection, analysis, and conclusion. This structured process is the backbone of scientific discovery. FAIR testing. Last but certainly not least, we unlocked the power of FAIR testing. You've seen how it ensures reliability in your results, reduces bias, and allows others to replicate your experiments. It's a critical tool for every scientist. So, as we conclude our exploration today, remember that the world of science is vast and filled with wonder. Armed with these foundational concepts, you're well on your way to becoming a skilled investigator and making your mark on the world of discovery. Keep asking questions, keep experimenting, and keep that curiosity alive. The scientific journey is just beginning, and the possibilities are endless. Thank you for joining me on this scientific adventure. Stay curious, stay inspired, and keep exploring the incredible world of science. Are you ready to put your newfound knowledge to the test? Let's dive into the next video and see how well you've grasped the basics of scientific investigation.